The last portion is combining our different skills together, looking at linear and angular speed problems, and then doing a problem where you've got to use linear speed and angular speed within the same calculation. So starting off here, a skater moves around the edge of a circular practice rink at a rate of 1 revolution every 5 minutes. The rink has a radius of 41 meters. What is the skater's linear speed in meters per minute? So since I'm using linear speed, I'm going to have to, at some point in this problem, use 2 pi times the radius over 1 revolution. That's what linear speed tells me. I've got to use that at some point. So let's start by writing down the pieces that I know. I know that I'm going to go for a rate of 1 revolution every 5 minutes. So since that's the order it gives me in the problem, I'm going to start with 1 revolution over 5 minutes. And I need to end up with meters per minute. So I need to get rid of this revolution. The only factor I know that's revolution is that 1 revolution is 2 pi times the radius, which in this case is 41 meters. Revolutions cancel out, and now I can see I've got meters per minute, which is exactly what I want in terms of my factors. So at this point I can multiply all that out. 2 pi times 41, and divide that by 5, and we're going to have approximately 51.522 meters per minute. The second example, a merry-go-round, spins at 1 revolution per 36 seconds. And we want to compare the linear speed of 2 children who are 2 feet away from the center and 4 feet away from the center. So once again, we're dealing with linear speed. So the one that's 2 feet from the center. We know that we've got 1 revolution per 36 seconds. So that needs to be our starting point. 1 revolution over 36 seconds. So once again, I want to find linear speed, and linear speed tells me it's going to be 2 pi times the radius over 1 revolution, or 1 revolution over 2 pi times the radius. Here I want my revolutions to cancel out, so I'm going to do 2 pi times the radius, which in this case is going to be 2 feet. I'm 2 feet away from the center. So now I've got feet per second. It doesn't tell me what my units have to be, and I'm just making a comparison. So this is going to be perfectly fine. And if I look at that, it's approximately 0.3491 feet per second. We'll do a second example now where the child is 4 feet from the center. Same exact setup, 1 revolution over 36 seconds, linear speed. So once again, it's going to be revolutions canceling out, and I need 2 pi times the radius, which is going to be 4 feet. Got my feet per second once again, and if I multiply all that out, I get 0.6982 feet per second. 0.6982, that is a 2 right there, feet per second. So if I make a comparison there, if I double the distance out, I doubled my linear speed.